Great. Hi, everyone. My name is Chris, and I brought Ancho, who's in the back with me, to present the DutchX to you today and to do a hands-on workshop. So what we're going to do, we're going to split it a little bit. I will introduce you to the mechanism and how we've implemented and how the exchange actually works. So you have a bit of a background understanding to then do a really hands-on workshop. And if you want to use the time and get a little bit bored because you know it already maybe, you can use the time to download some of the things that you might want to have later for the workshop, which is Node. You should have a browser with MetaMask, and you should have some Rinkeby Ether, and if you want, Docker. So for now, I give you a bit of background information on the mechanism, and please feel free to ask some questions so you have an understanding on how the integration then later works that Ancho will run you through. So what is the DutchX? It's an open trading protocol for ERC20 tokens, and it's using the Dutch auction mechanism to determine a fair value for tokens. So what do we mean by open trading protocol? It's really a permissionless layer that anybody can build on top of. So to understand how we came up with the design, let's go and revisit just a little bit on how usually exchanges look like, because usual exchanges are actually order book based. So what does that mean, order book based exchanges? You can see here an order book where people place their bids and their ask for a specific token expressed in another token, for example, and really all that is a continuous auction because it's a pay by bid, so everybody pays basically what they ask and bid for, and that leads to discriminatory pricing. Everybody pays something different. So there are some things that are flawed in this model, and I'm just going to name a few. One, for example, is front-running, a practice where anybody, possibly the trader or the exchange, act on information that is available to them beforehand, before that's available to others. You will have high-frequency traders in this kind of model that really act on speed. You might have overlapping order books, which is basically where people, where if the order books is such that it overlaps and there's no automatic matching of the order, that would mean that there's an opportunity for arbitrage. You might have a big spread, which is the difference between bid and ask, and you can have high slippage, which is especially if you have illiquid markets where there is a very voluminous order book. It can happen that a few orders or a market order really moves the price a lot. So there are some disadvantages you have in this model, and what many decentralized exchanges now have done is they've taken this model and brought it to blockchain. But actually on blockchain, some of these difficulties are actually magnified because you don't actually have continuous time, you only have discrete time, namely the block time, right? So we've said we are going to take a completely different alternative approach that will be hopefully fairer and can be brought onto the blockchain. So we've actually implemented two different auction mechanisms. One is the batch auction and the Dutch auction. They actually go hand in hand. So the batch auction is where we say, imagine you're trading, somebody's trading token A for token B. And those who want to sell token A, in a first instance, batch all those tokens A together. Okay, so everybody comes and deposits their A. So we're batching it to then be auctioned off in a second stage where we use the Dutch auction. Many might be familiar with this concept because some token sales are happening with this Dutch auction format, which basically is you start with a really, really high price that will never be reached, and then you have a dropping price function, so the price decreases. And during this, bidders are actually active and bid the amounts that they'd be willing to buy at this price. This is really great because, so in the end, though this person has indicated that they're willing to buy at this high price, in the end, when the auction clears, everybody pays the same final price, which gives everybody who bids an incentive to actually reveal their true willingness to pay, because they will either pay the price that they are bidding at or a lower price when the auction clears. So how have we applied this exactly, these mechanisms in our model, which we call the DutchX? So there are two stages. I briefly mentioned this. It's the stage before an auction and after an auction. So let's briefly run this through an example. Selling token A for token B. So people are depositing token A, and bidders use token B to bid for token A. So you have the stage before an auction where everybody deposits. If there's a threshold reached and the time of the past auction has passed and has finished, the new auction will start, and exactly in this mechanism, with this closed sell volume, the auction will run. So how does this look like over time? So essentially, there's only ever one auction, token A, token B, ongoing at the same time. During this phase, already the collection for the next auction is ongoing, so you can use this time until the next auction starts. So you have sellers deposit, bidders bids, payouts are made, and this you have on repeat, essentially. So if you might ask, how long does an auction take? So we've designed the falling price function to reflect that after 6 hours, we'll reach the prior closing price. So we always start at twice the prior closing price. After 6 hours, we reach the old one. Obviously, we don't know when this auction will end. It could be longer or shorter, but after 6 hours is a good indication that that was the prior market price that was reached. So to later give you kind of your toolkit that you need to integrate and build on top of the DutchX, I'll run you through also the token design and the mechanisms that we've used in creating the DutchX. Oh, that was too quick. Let's start with this. So there are basically 3 things that are intrinsic to the DutchX. One is something that we call Magnolia token. The Magnolia token is something that is used for fee reduction. It's minted per trade and generated per trade. So 1 Magnolia is generated for every ether worth of trade done by the trader on the DutchX. It has to be on a whitelisted pair in order not to have fake tokens on there to just generate Magnolia. If you're interested in the details, come find me later. But essentially, Magnolias are tradable on a secondary market, but they're locked for default, and they need to be locked to make use of the fee reduction. Fees can go down to 0 in the current development of the DutchX smart contracts if a user holds 10% of the Magnolia market. And it's a step function to incentivize. So this is Magnolia, keep in mind, is just an intrinsic token by the DutchX, created for trades, and incentivizes basically the current trades and the reoccurring trades of traders on the DutchX. We also allow fee payments in OWL. So half of the fees can be paid in OWL. If you're wondering what OWL is the token that you get for locking down GNO, which is the Gnosis token. Nobody has to pay in OWL. It's purely optional, and those fees paid in OWL are burned. But actually, what's the way more cooler part, and the greatest part of the DutchX, I believe, is this part of the liquidity contribution. So, meaning all fees paid in the participating token, which is the only other option rather than paying half in OWL, all those fees actually remain in the DutchX ecosystem. So they're not being taken out, but it's sort of a liquidity contribution and goes towards the next running auction as an extra sell volume, kind of incentivizing, again, continuous use, and you might actually be benefiting from people paying fees rather than you might be a net benefitor, if you will, of the fees. So that's pretty cool. So some advantages of the DutchX mechanism, and this is just a selection. You can't really have a front running because A, it takes a very long time, and B, everybody pays the same price in the end. Also leads to less volatile markets. You also only have a price point approximately every 6 hours. We also strongly believe it's a fairer price finding mechanisms because bidders are incentivized to take part when they have the highest willingness to pay. And as they do this, and because they do this, this benefits the sellers as well. Because there is not really a reason to kind of mask your true willingness to pay to kind of get some profit out of a trade. Also, there will never be any gas costs incurred to traders trying to fulfill the same orders, because all orders are actually fulfilled. And really, there will be no high-frequency traders because it's a super slow mechanism. So it is slow, and this is intrinsic to the DutchX, and this is probably its greatest features and advantage. So it is slow and compatible with the current technology that we have on blockchain. I've pinpointed 2 other advantages, kind of that leads the whole thing also to be an open protocol, as I stated at the very beginning. One is that the whole mechanism design and how the smart contracts were written were actually for the integration of other smart contracts. So everything happens on chain. There's no need to sign any trades or orders off chain. And if you participate, or the smart contract participates as a seller, there's really no strategy needed, because you don't need to have a price perception when it's right to take part in the bidding process. And the outcome thereof, and we've designed it this way, so basically the outcome, if there is enough liquidity and volume, is also a reliable on-chain price oracle. Right, so what does this open protocol mean? I've just listed here a few layers where you can kind of see this manifest itself. There could be various interfaces built on top that all lead to the same protocol layer, basically pooling all the liquidity in one smart contract, which benefits everything. You could think of also wallet integration, because wallets really also have the need to exchange tokens and could be seen to show kind of your wallet balances in one particular currency, etc. Then there are these fully fledged on-chain apps that might also have a need to exchange tokens, like a DAO, or like, say, the outcome tokens in a prediction markets could also be traded on the DutchX, essentially. Some other smart contract interaction could be, for example, that there's a transaction scheduler or just a lending or buyback contract, whereas I'm a particular fan of a buyback contract, maybe even like a buyback and burn, because I know that many token projects actually have the need or want to implement something where they buy back and burn their own tokens for whatever or various reasons, and they could implement this in sort of a smart contract to be really committing which auctions they would take part in, and say input 500 Ether in auction index 17, 19, 21 to kind of buy back their own tokens. So the problem with buybacks, for example, is that often liquidity is kind of stuck on one central exchange, and it's really hard to move between different exchanges. So kind of all of this creates liquidity, and then you have this price feed outcome, which then in turn can also be used by all various steps, wallets, crypto funds, etc. So that's pretty cool. So how does this all work? And Anshu will go into detail here as well, but just to show you the contracts that govern the DutchX mechanism, we've implemented this proxy contracts where it makes it possible for us to update the logic and everything that I've explained now how it works, by still keeping the data, the funds, the history, people's balances in the DX in the proxy. We also need one external price feed that we are reliant on, and we've implemented to point this to the MakerDAO price feed currently. So that's the Ether US dollar price feed. We have this fee reduction token contracts, which is the Magnolia. So basically developers interacting with the DutchX would do it either on proxy level, or if it's about Magnolia, on this level. These two contracts don't really belong to the DutchX, but I've just listed them for you to see the complete picture, because it then also includes the owl burning, which users may, if they want, use to pay for half of the fees. Okay, so we don't have yes decentralization, no decentralization. It's really not binary. It's really a scale of decentralization. So most decentralized exchanges, when they say we're decentralized, what they mean is they are non-custodial, which means they don't hold the user's funds. But we've actually tried to list here all the instances what makes something fully decentralized. And as you've seen, the workshop is called Biddle on the first fully decentralized exchange because we're actually almost there. So we've implemented that it's non-custodial and that everything happens on-chain. The next step, there are a few parameters that are modifiable on smart contract level. And the next step is to hand these over to actually the DAO governance. And then we're not very far away of launching this on ENS and IPFS. So what is the current status? So we've been live with the main contracts for a long time now. We're calling it the pilot because essentially nobody is in control of this current version. Nobody can change the modifiable parameters at the moment until the DAO will relaunch the smart contracts, effectively enabling all these modifiable parameters, which are, for example, changing the whitelist. So the list that says which tokens will create Magnolia, changing the price feed, the starting threshold for the auctions, and a few parameters that are modifiable. Also, we'll be sort of quietly launching our graphical user interface, available also on mainnet by next week by DevCon. And DAO governance is really ongoing, and listen out for more information on this. This is really, really interesting topic, and this will probably be the very, very first exchange governed by a DAO. We have really extensive documentation, and Anshu will show you this in a minute, but if you are interested even further, we will put more on DAO governance and hackathons, etc. on here very shortly. So if you now have questions about the mechanism, so how it works and how we've implemented before we move on to the actually hands-on part of the workshop, we can take some questions now. Thank you, Hannes. If Dutch auctions are implemented, the Dutch auction originally, so the name actually comes from the Dutch flower market, where they started with a really high price and falling, but essentially what you need is a something fungible that's interchangeable, and then bidders will get it at the lowest price. And I actually believe some centralized exchanges or stock markets do this for overnight trades where they accumulate, and then the very first auction they do is a Dutch auction when they open the markets. It's implemented in some cases, and some ICOs and I think even Google, IPO did it. Like it is. No, I don't know. Sorry. In the back? It's not, and this is a really good idea. It's not. So basically, the way we see it is that a seller would kind of post a very slowly and securely executed market order, whereas a bidder really takes part when, well, basically they will have a limit order because that's the maximum they'd be paying, so that's more a limit order. But there could be a design for somebody building on top of it, designing a smart contract where you can actually imitate limit orders. So this would be really a good biddle idea. Yeah. There was, yeah. So two really good questions. The first one is, originally the thought was that we also have the prediction market as part of our kind of product system, that the prediction market outcome tokens would also need to have an exchange where it's peer-to-peer tradable rather than a logarithmic market scoring rule, which is currently the market maker on the prediction market. So that was the first goal. If this is very realistic and soon be able to happen, not entirely sure. And then also, yes, it is something that we think is missing in the current ecosystem of the Ethereum, which everybody could benefit from. What are we doing to get liquidity? Well, we're giving these talks to say what a cool thing it is. We're trying to make the ecosystem aware. We're trying to implement really easy documentation for people to build on top, to add their own token pair. We've also written some liquidity bots that anybody can just take and sort of ensure that there's a minimum liquidity, because it is a two-sided marketplace and you need both sides of the market for the exchange to work probably. Having more bidders means having more sellers means more bidders, so what is first? And to kind of initiate this, we really encourage these minimal liquidity bots. And coming back, I don't want to kind of not answer the business model question. Obviously, currently in the smart contract and how it's designed, half of the fees can be paid in OWL, which is by locking down GNO. However, we are fully aware that once this is governed by a DAO, they are free to do with the smart contracts what they wish, and they might vote for an entirely different fee model. So yes, we've kind of making ourselves redundant, but we also think we've built something really great and learned a lot in the meantime. Yeah. Well, currently, this is the thing is, what you need to have is at the critical point, you need to have enough blocks mined for transactions not to be front run. So what happens at 6 hours, the slope is so small, so the price function first decreases a bit quicker and then it flattens, and around 6 hours, a 1% price differential is mined in 20 blocks. So and because this is also really great for illiquid markets, you need this time to make sure you collect already those sell orders for the next batch. So that's why currently it's 6 hours. But as you've heard, we're working already on research on the next one, and Alex was mentioning that three minutes for order collection is probably something we will aim for in that diffusion exchange. Yes. We've thought about it, but currently that is not in our scope, so it's really only ERC20. Though you can use Ether, and we'll wrap it for you. But we won't unwrap it for you, to incentivize the ecosystem a little bit to use wrapped Ether. But yeah. Yeah. Ooh. Yeah, sure. So the rationale of creating Magnolia is to incentivize high volume trades and those who use who trade on the Dutch exchange to stay on the Dutch exchange, because the Magnolia market is inflationary. We just mint for every Ether trade, right? Or equivalent of an Ether trade or fraction thereof, we mint the exact amount of Magnolia, but your fee reduction is a percentage that you hold in comparison to the entire Magnolia market, which means if you don't trade anymore, it reduces and your fees will increase. So you have an incentive to actually continuously be on it, and we want to really give value to those who bring the liquidity to the DutchX, because an exchange can only live by having liquidity on an exchange. So we want to kind of make it easy for those who trade a lot. Well, that is what Johannes asked before. That is sort of currently our business model in the DutchX, which we're aware the DAO might decide upon differently. Exactly, because so 1 hour can will be worth $1 in using fees on the DutchX, but you might acquire it on secondary market either cheaper, or you sort of got it as a coupon by locking down your GNO, so it's a value to GNO holders, right? Mm-hmm. Like I'm just translating it into German. It basically means into English. Yeah, like a coupon. Yeah, like a, sorry. Does that make sense? Any more questions on the mechanism? Otherwise, we move on to everybody can get out the laptops and do some hands-on workshop building. One more question? Well, we take a long time to execute them as well, right? So obviously it can still be volatile, but we expect it to be much less volatile than the normal order book markets, because you can't have these slippage in order books, and you only have a price point every 6 hours, and we would imagine that that is more reliable. So the oracle that we report actually as a function is always the last. So it's a weighted average of 2 auctions, which are the opposite auctions. So AB happens at the same time as BA actually. So it's a weighted average. We report this as a price oracle. But another good idea for building on top of the DutchX to come up with different price oracles, which is maybe a median of the last 10 or something completely different, or between some various price A for B, B for D, D for A, and then you might have some other kind of price mechanism, price oracle that you think is more robust. That could be an idea. Yes. Yes, of course. Yes, it could theoretically be 1 hour. This means that then the cell token A has appreciated versus B, but that means because we run both auctions at the same time, that means that the BA auction is very likely to run much longer than 6 hours, reflecting that price point, if you know what I mean. And the next auction would then only start after the latter one has finished, because we always start the opposite auctions at the same time. Yes. Well, the idea for the seller really is that by the bidder's incentive to reveal their true willingness to pay. Actually, I don't know about the expected revenue, but that's a good question. That would be good. Yes, that would be good. Let's chat about this. It'll be good to have an idea about this. Cool. I will pass on to Ansho.
Hi. Does it work? Okay, so thank you everyone for coming today, this afternoon. Very excited to be here. My name is Angel. I'm an engineer at Gnosis, working for the Dutch Exchange. And today I'll be presenting how to build on top of the Dutch Exchange. It's gonna be a practical session, but we're gonna introduce a little bit to some tools and documentation we have, and then we're gonna try to do a practical exercise, a small application, just to give a small taste on how it is to build. So first, we're gonna start with some documentation. I'm gonna show where to find the smart contracts. Also, I'm gonna show where it's published, in which networks, the addresses. Instead of showing the smart contracts like the Solidity code that could be a bit cumbersome, I'm going to show how can you use them for any use case, so you get an idea on which functions do we have and how can you use it, and maybe you come up with a nice idea on what you could build on top of it. So the the tools we're going to be presenting is the CLI that is going to read straight from the smart contracts, and the API that also reads from the smart contracts, but is more for providing an easy entry point for people that doesn't have this knowledge about Ethereum, is like any other exchange, providing a REST API and making things easier. Also, it's useful for building applications easier. I have 3 examples here also about other things we could do just for developers. Is for example, the first example is how to migrate our contracts in a local ganache. This is very useful for speeding up the development, not depending on testnets. But we won't have time for this workshop, but I just put it here because I'm going to share later the presentation, and you can do it if you are interested. You can do it at home, or you can ask me later questions about it. Also, there's another example that I think is very interesting. It's about building a contract that depends on the Dutch exchange. Yeah, so I'm going to give you it's like a guide, step by step, how can you do this. And then we also provide some front ends ready to go. This is boilerplate code with our contracts and some wrappers for them. So the first stop is here in the documentation. Chris already mentioned about this community section, but here you'll find the official documentation about the smart contracts, where you will find further information about the mechanisms. Also, Chris also, already mentioned that this is an open protocol. We didn't build it for ourselves. We wanted to be like users of this and release it to the public domain. This is why it's open source, and this is why now we don't hold the manager powers of for changing any of the parameters, and this is why we're working right now in let it be governed by a DAO. We have a section for market makers, for making them aware of what they can do to make markets here. The API, the CLI, security information, where you can see the audits that we've passed with this contract. It was very important for us in the design, and because we want to be heavy users of these DutchX mechanisms. We want to make it secure. And this is a very interesting part for developers if you want to build something on top of it, because there's examples like guides that you can follow through. It's explained like step by step. I think it's very useful for doing it. And today we're going to do this very first example. Also, another interesting thing about the documentation is here we provide information how to add a token pair, and I think it's a cool thing about the DutchX that you don't need any kind of permission to list a token. Anyone can do it. It's just you with the smart contract listing the token, and this is in contraposition to other exchanges, very different, where you have to apply a process, and maybe you have to even pay or wait for a long period, or maybe your token gets rejected. Not here. You can list any token pair and make a market yourself if you want to. And for making the market, we have these bots. You can build definitely the different bots, but we provide ones that you can use, and we really encourage people to build their own. But we have several ones, but the two more important is the sell bot and the buy bot. The sell bot is the one that ensures that the auction start, is ensuring the sell liquidity, and the buy bot is going to track the market price and the price of the auction, and when the auction hits the market price, they're gonna send a post order. And the last part I want to show you from here is the smart contract addresses. Because as you can see, we deploy the contracts in Rinkeby, in Koban, and in mainnet. And we provide here Etherscan links, so you can check out there the code, because we validated all the contracts, and the addresses. As Chris says, we built a lot of tools, but the core of it is the contract, and the mechanisms are built on them, so it's fully on chain, and that is I think a cool thing. I already showed the addresses where you can find them. I'm going to show now where you can find the smart contracts. An important thing, all our repositories is in the Gnosis GitHub, and they are all public. And if you filter like by DX here, you should see all our projects. We have plenty of things we're working on right now, but the one I want to show you is the contract. That is where we have all the tests for our contracts, the contracts themselves, and many utilities and scripts. For example, for making easier for anyone to list a token, we provide a script. Here is very interesting, within the contracts folder, these two contracts that Chris already showed in the graph. This is the proxy contract, is the one we are going to be interacting with. This is the master contract, that is the one holding the logic. I think the contracts are very easy to read for if you are used to read Solidity. They have a lot of comments. It's not, you can read it through, but it's not the point of this this workshop. By the way, Alex wrote them. I think he did a very good job, and he passed all the audits. And they didn't find anything important, so yeah. Other thing that we provide is the npm package, that is just what you saw, the project you saw, like DX contracts, with the same thing, the utilities, like some migration helpers and things like that. But one thing that is cool that we provide here is in the compiled contracts from like the truffle abstraction, where you have the AVI and the addresses. So you can add in your project this npm package, and then depend on these compile contracts, and you don't have to worry about the networks, because we provide here the networks addresses for all the contracts. Yeah, so I said that I was not going to explain the smart contracts from in Solidity code, but I want to just point out some things that you can do in the smart contract by giving you some user types and user cases. For example, the market maker, he can add a token pair. And this is what I said it before, is a cool thing that you don't need to hold any permission. You don't have to have any special permission to do it. This applies to any user. Any user in the DutchX have an account. This is an Ethereum account, and they can get the balance for any token deposited in the contract, and they can deposit tokens, and then can withdraw tokens from it. I put here this gray box that is we don't depend on. It's not from our contracts, but it's. I'm sure everyone knows about Rapid Ether, but I just put it so we are all in the same page, and also it has to do with the example I prepared for later. In the DutchX, we exchange ERC20 tokens. Ether is not a ERC20 token, so the way to solve this is there's a contract that is called Rapid Ether, where you send the Ether. The contract will take that Ether and add it to your balance. And this process is called wrapping Ether. There's the inverse process, where you tell the contract, I want my Ether back, and they will decrease your balance and give you back the Ether. And this is called unwrapping. Chris already talked about the sellers. This is the most simple case in the Dutch exchange. What can a seller do? Very simple. They can submit a post sell order and then wait until the auction is finished and then claim back the tokens. So it's a very, very simple use case. I think it's cool because they don't have to worry about the price. Since this is fully on-chain, and you don't have to worry about the price, you can do a simple logics to exchange any token for any other token. And I think this is very cool for if you want to use it in your own smart contracts. The bidder is a more complicated case, but it's not that complicated. They can get the sell volume from an auction, they can get the buy volume from an auction, and then they can get the price that is decreasing with the time. And when they know the maximum price they want to pay, and when the price is right, what they can do is they submit a post buy order. And a cool thing that they can do is they can claim back the tokens at this very moment. They don't have to wait until the auction is finished. So they can. The sellers had to wait until the auction is finished because they don't know the price. But right now we are submitting our order with the maximum price we are gonna pay. But the price is gonna keep going down. So we can claim at this very moment at this price, and then the auction will clear in a lower price, and we can claim the remaining tokens. I want to show the CLI. So if you want to try it out, this repo here, like I'm gonna leave it for a second, but it's in Gnosis DX CLI. If you wanna try it out, it's just cloning this repo, and you can run all the commands. I'm gonna show how it is. So we just clone the repo. One thing about I'm going to show the project a little bit, but okay. So this project has like a CLI for Koban, one for mainnet, and one for Rinkeby. And you can configure, add configuration per network, like for example, the tokens you want to use in that particular network. And you have a local config file. But out of the box, you can just run, for example, give me the state of Rapid Ether versus Raiden. What this is doing is getting sorry. Okay. This is the execution of the. I just give the command. In this case, is state, and this is the token pair. This is pulling from Docker the image, the last stable version we provide. If we update it, it's gonna update the new one. Since I have it in my laptop locally, it's not doing that in this moment. But here it's displaying a lot of information, and this is a cool command we can use just for get a sense of what is happening right now in the smart contract. In the smart contract right now, the action is currently running, and it started three hours ago. So we are in the middle of this 6 hours time. So we will reach the last auction closing price in 3 hours. This is the sell volume, $1,000, that in rating is this amount. We display here two prices. This is the current price. So if I want to submit a buy order right now, this is the price I have to pay. But since we didn't reach this 6 hours time, we will be paying more than we should. Actually, we are 35% over the last closing price, so I guess not. We should have to wait a little bit longer. Here in the buy volume, you can see that nobody bought. It makes sense. There's a lot of commands. If you type the help command, you'll see all of them. But here in the documentation is very well explained. You can, for example, get trades and filter by dates, get the last auctions. One cool thing about this CLI is that you can actually trade in the Dutch exchange. So for doing that, it's just you just have to configure one account. The way to do it is you can just copy this file here, the local config file. We provide this example. As you can see here, you can provide your mnemonic. This file is ignored by Git. So yeah, it's just you just write your mnemonic here, and you'll be able to trade. So you can do like withdrawals, deposits, post sell orders, buy orders. You have all the documentation here if you want to take a look into it. Another cool thing we provide is the API, and it's meant to be like a easier access for anyone. But it's also for if you're developing. As you can see, we have the API in Rinkeby and in mainnet. So if you're developing, maybe you're in a testnet, you can use this one, and the mainnet is giving you the real thing. As you can see, there's a try button, and here, I don't know, you can see what is going on in the smart contract just by filling these inputs here and hitting the try button. So this one is taking a bit, but because this one, since we are reading directly from the smart contract, we didn't enable cache right now. It's reading from all the events in the smart contract. It's taking a bit, but I think right now it should be immediate. So these are the tokens that are declared right now in the smart contract. And it's a cool thing. So since anyone can list a token, you can just use this and see a snapshot of what's the token list in the exchange. Okay, I don't know if you plan to follow this exercise I prepare, but I'm gonna do it myself. Yeah, basically we're gonna build a small web application with just one input and one button for depositing money into the Ether into the Dutch exchange. I think it's very representative because it's gonna show us which contract do we have to use, how does this messaging thing work, how to wrap Ether, and these kind of things. So yeah, if you deposit something to the Dutch exchange, you first have to call this proxy contract, and the proxy contract is going to do a delegate call to the master contract, as Chris was explaining before. I prepared this diagram because in reality, in this application, it seems very simple, like just one input and one button. But in reality, we will need to do three things. We first need to wrap the Ether. I said it before. Ether is not ERC20 compliant, so we need to send Ether to this Ether contract. So here, this guy here, the user one, is the one using this application. This one here is the wrapped Ether contract. In red, I represent the addresses. I didn't want to write like hex. Here we have the DutchX proxy. Here we have the DutchX master. So for the wrapping of Ether, we just have to send a 0.1 Ether using the deposit function into the wrapped Ether contract, and this will add the balance for this user of 0.1 and take our Ether, of course. Then this second step here is to set an allowance. To understand this better, I think I'm going to show the smart contract again. All right, so this is the deposit function. It has two parameters. The first one is the token address. In this case, it's going to be wrapped Ether. And the second parameter is going to be the amount. In the example was 0.1. So the very first thing that it needs to succeed, so the very first thing we are going to require is that, sorry? Yeah, sorry. Okay, so there's two parameters, the wrapped Ether and the amount. And the first thing that must succeed here is the transfer from the user to this very contract. This is the proxy contract we're talking to. So in order to succeed this operation, we have to, if you're familiar with ERC20 compliant tokens, what you need to do is to set an allowance, like I'm user one, I allow proxy one to take 0.1 tokens from me. And this is exactly what we are doing here with the approve function. We're saying, I'm user one, letting proxy one to take 0.1 Ether from me. This will set an allowance for 0.1. And at this point, if we do a deposit, it's gonna succeed. How a deposit works? We send the transaction to the proxy. The proxy is gonna do a delegate call to the master contract, and the master contract is gonna, you saw it in the code before, is gonna ask the wrapped Ether, can you transfer the it was difficult to represent here the proxy contract, but if you can see here, I wrote the proxy one address, not the master one, because in reality it's being the address used is this one. So it's requiring to do the transfer. So wrapped Ether is gonna check the allowance, and it's gonna say, do the proxy one have allowance to for this user one person? And it's gonna say yes, so it's gonna decrease it. Then it's gonna decrement the balance of this user and increment the balance of the proxy. Once it has done that, the master contract is going to increase the balance of the user, and this is how you do a deposit. This seems more complicated than it really is, but it's important to understand these steps because it's what's going to happen in this example. If you in this example is this very first one here. By the way, this project, DX Examples Dev, is a group of examples we prepare for developers. I think they are every example shows you one thing you can do with the Dutch Exchange, and this one is for learning how to do a deposit and learning how to use the contracts and so on. So we're going to start by creating a basic web. Just for making it easier, we're going to use create React app. Can you see it in the background? Is it too small, the fonts? Okay, so the first thing we are going to do is to create a basic React application. And this React okay, and we just run it. Okay, so we have the application here, and we are going to modify this application to interact with the Dutch Exchange. So first thing I'm going to do is to add this folder into here to see what is in the project. So this is what React scripts create for us. And yeah, we don't need this image. We are gonna follow this. I'm gonna close some windows. I'm gonna follow this guy. We provide here just some simple markup to ease it. It's very simple. I'm gonna show it to you right now, but. Okay, so the application, I don't know if you are familiar with React, but the part of React is very, very small. I think you can understand it and follow through. We map the application with two properties. One is the amount, that this amount is binded to the input, that you can see it here. This message is what we are going to use just to display the success of the operations. This message is here. So if there's no message, we don't show it. We also create a small button that if you press it, we are going to call this deposit function that for now is just gonna show a small message. I added here some CSS just for styling a bit the message and adding some air in the components. And you just copy paste. And right now we should have something like this. Okay. And if we press it, we see the message like, I think you had to do something else to make it work, right? Looks good enough. Next step we are going to do is to install Web3. I'm going to use 1.0, but you can use the version you want. And once you use it, I'm going to create like a small utility, this Web3 JS, that incorporates. The only thing it does is pretty standard. We get the Web3 library we added, the 1.0, and then we assume that MetaMask is or somebody is injecting Web3. We take this provider and we construct the Web3 object using this provider. So I'm going to do that. And then, of course, we export it so we can import it here in the main application. Okay. We're going to change the implementation of the deposit function. So instead of the I think you have to do something else. Message. I think it was installed in the Web3 still. I don't know if I cut it. Any questions? Sorry if it's too technical. I don't know the background of everyone here, but we planned to do it hands-on and show how to do it. But yeah. Yeah. Yes, yes. Okay. Okay, so this this is just not. This is like. You mean the watch command? Okay, so so the watch command is you just set a time, like for example, every 10 seconds or 5 seconds, and you run another command. Because the question of Rafa, sorry, the question from Rafa is, how can I make the CLI to execute give me the state of the action every 20 seconds? Yeah, this in Linux and Unix you have this command watch, and you can set the time and set here the command. Here, every 5 seconds is gonna run the command. So now I'm just showing the time every 5 seconds. So you could do the same thing. I think it should be something like DutchX state and then the action, and it's gonna refresh every. But it's kind of hacky way. The way to do these kind of things is to have a real interface. Yeah, not using the CLI for that. Anyways, next step. Yeah, this is working. Okay, so the new implementation is getting the account from Web3 and show it here. And as you can see, is displaying it. Next step is what do you need to interact with a contract in Ethereum? You need two things, like the address and the AVI. Since I showed you before the addresses in the documentation, we could go to the master contract in Etherscan, and there's this tab here, the code, where we have the AVI that we can just copy and bring it to our project. And we can do the same with the Rapid because it's the other is the other contract we are going to be interacting with. All right. Oh. All right. Okay, so next step is we get the ABIs from both of the contracts, and we set the addresses. It's pretty easy. And we are ready to instantiate the contract. So this function here is gonna be called once the React application is added to the DOM in the browser. So this is doing is creating the contract out of the ABI code and the address of the Dutch exchange. This is going to create the Rapid Ether contract with the ABI and the address too, and we are recording, saving it for later here in our application. This is our first interaction we are going to do with the Dutch exchange. We're going to call the auctioneer function that will give us the who is running the DutchX. And as Chris said, nobody is running it right now. So we should see, if we check on the terminal here in the console, we see that now this message is being read by in the smart contract. The auctioneer is the address number 1, that nobody owns that address. Okay, so let's do next step. If I think if it's too complicated to follow these steps here, you can try to follow at home. This function looks very complicated, but it's actually very simple. We are getting here the balance of Ether in a pretty standard way. Here we are using the Rapid Ether contract to get the balance of our current account. Here we are using the Rapid Ether contract to call the allowance function that will give us what's the allowance for the DutchX and my account. And the last one is calling directly to the DutchX and asking what's the balance for Rapid Ether and my account. This is going to return 4 promises that we will wait here for them, and we will show a message. So now it's becoming more interesting, the example. But in order to see something, I guess we have to add a new button. Add balances. Okay, that if we press it, we see that I own 10 Ether, and the Rapid Ether balance is 0, the allowance for the Dutch exchange is 0, and the balance in the Dutch exchange is 0. Okay, so we're going to do the next thing. So is how to wrap Ether. I'm going to just copy it and explain it in the Visual Studio Code. So the wrap Ether function is actually very simple too. We just use the Rapid Ether contract, and we call the deposit function using this value. That is how we set the amount of Ether we want to send. We pick it from the input and we convert it into way. So this way, of course, adding a new button that just wraps Ether. Now we can enter the amount. Remember that we don't have right now any Rapid Ether, so I'm gonna just gonna try to increase it. I don't know if it helps, but just so we don't wait a lot. Right now we have 0. Once this is mine, I didn't show it, but the the wrap ether function is going to wait here until the transaction is mined. And once it's mined, we are going to just print a message like, we have wrapped this amount of ether, and this is the link to Etherscan, so you can check it here. If it takes too long, I have a lot of pending. Yeah. Sometimes I don't know what's happening with the MetaMask. I have to. It's here. Yeah. So yeah, if now we get the balances, we see that we have 0.1 rapid ether. I'm gonna continue with the setting the allowance thing I explained before. It's pretty similar to what we did now, but calling it to a different function. So we use the same contract, the rapid ether, but this time we approve the Dutch exchange for this amount. So I'm going to adjust this. Okay, you see this method, maybe it's too small, but by approving this action, you grant permission for this contract to spend up 0.1 of your rapid ether. This is exactly what we want. So I don't know which. While it's being mined, I'm going to continue with the deposit. If you remember, we had like a trivial implementation of the deposit that just showed the account, and we're going to change that into other thing. That is going to, if we now have the allowance in place, we are ready to do the deposit and succeed with the operation. So the only thing we need to do is call the deposit function in the Dutch exchange using the token we want to use and the amount, in this case 0.1. The same as before, we wait for the transaction. Okay, the transaction was mined. Or not. I'm gonna do it again just in case. Let's check here. Okay, 1 minute ago. So I think it's mine, but I don't know why sometimes I don't get MetaMask is losing connectivity or something. I have to just push it doing this, and it's, yes, you see? I don't know what's going on. Anyways, it worked, and now I should have the allowance. So we are ready to do the deposit. We didn't save here. Now we do our deposit. And once this deposit is done, we will have a rapid ether in our balance. From that moment, we can use that balance to trade in the DutchX. Here we went step by step, but you can of course, do it all at once. Yeah, improve a lot this application. So one way you could continue this application is like adding error handling, adding support for other networks, maybe unwrap, withdraw. Here I provide an example on how to. I did this myself, so you can check it out here. Also, there's a lot of things else you can do. For example, instead of using Rapid Ether, you can use any token. So that would be a nice thing to continue doing. Also, now that we have a balance in the Dutch exchange, it's cool that we just call this post-sell order function and this post by order function. Now it's very easy. It's going to take from our balance and put it in the auction. We can also like list token pairs and allow to select a token pair and then participate in an action. Another thing I want to say is that if playing with this you feel like creative and you come up with a cool idea, we have a Gitter channel where you can share it and maybe you get like other ideas or even help. But if you are looking for ideas, we have also in the documentation a list of them. And also, Chris, I don't know if you want to comment on the inspiration ideas.
Can we switch this on? Is it? Okay, cool.
Yeah.
One reason, as Ancho was mentioning, the one reason why you might want to have that balance in the DutchX rather than in your wallet, and every time when you make a trade to deposit it again in the right amount, is because you'd be saving a lot of gas if it's actually deposited in the. That's why frequent traders, that would be one way to go. What we've done is, Johannes actually asked before, what are we doing to incentivize people building on top of it? And we actually believe that it is a really great product that will help the ecosystem grow and has a lot of cool features and functions. So we will be putting, before DEFCON next week, hopefully, a few bounties on Gitcoin just to incentivize people to actually start and get that traction that you need going on the DutchX. We also have the Gnosis Ecosystem Fund, where people who have a real cool idea, their own, or any idea that they might take from our inspirational page, that they can come up with a proposal and be actually rewarded something if they come up with a cool integration case. We've listed a lot on Read the Docs, but we just wanted to pinpoint a few that we think might also have an intrinsic value for other people doing it. One is maybe writing some arbitrage bot to other exchanges. Obviously, there's arbitrage bot there is something to be gained for those people who are writing these bots. Additionally, not only to other exchanges, but I mentioned at the beginning that it's we always run the auctions A, B, B, A at the same time. And kind of when you reach those 6 hours threshold where you have the prior price, it's not really possible for both to continue, because that would mean that A would depreciate against B and B would depreciate against A. So at that point of time, it would be good to close the lesser volume that's remaining in one of the auctions by just having a bot run between those two auctions. Then somebody in the back mentioned this before also, maybe imitating limit orders, which is very common on other exchanges. There's still so much data analytics for like a graphical user interface that could potentially be done on it, and sort of a notification service, because the way it's currently the smart contracts work on blockchain is that once an auction has finished, we can't just deposit it back to the wallet that it came from. The user actually has to come and claim it actively and then also withdraw it. So I seem to be really loud now. So that like a notification service somebody could sign up on, that would be also one possible idea of really loads of different ideas. I also mentioned buyback, token buybacks and burn. Could be lending contracts, anything really. If you need inspiration, come also to our Gitter or read the docs or talk to us. It'll be really cool. Yeah. Do you have anything to add, or should we do a Q&A?
Yeah,
like
Q&A.
Do you have any questions for Ancho? No? Well, we'll be around a bit longer if you're too shy. Come talk to us afterwards. Cool, thanks.